Today we are going to talk about RGB LEDs. RGB LEDs are actually three separate LEDs combined into one bulb. These represent the primary colors when we're talking about light, and we're able to use them to create many other colors that you might want to represent. So let's look at how they're essentially designed. There are 4 pins as opposed to the 2 pins in an LED, and typically how they're designed is, just so you know, we have our LED, we have a shorter pin, a very long pin, and then usually 2 shorter pins. And so the way that you orient them, the way I always think about it, is it goes red, cathode, green, blue. And cathode is the longer one. So this is going to be red, cathode, green, blue. And that's how you orient it. And if you keep it this way, where the cathode is the second from the left, it's always the right orientation. Now, I will talk in a minute, there is something called a common anode. It's a different kind of LED. We're not going to be using it. So for our purposes, you can kind of consider that's not what we're going to deal with. We're going to use the cathode. And I'll talk about why they're different, and we'll get to that one in a second. Just as a little bit of a review, LEDs are diodes. They allow electricity and current to flow in one direction, like that, and not the other way. And so if we have a positive voltage applied to the anode, like about 2 volts, the light will turn on, and the cathode goes to ground. RGB LEDs operate in exactly the same way. Current flows from anode to cathode, just like before. If you apply a positive voltage, 2.2-ish, on any of the anodes, there will, and a ground is on the cathode, the light will turn on. But there are 2 different kinds of RGB LEDs. So this is where the little bit of confusion comes in. Okay, this is the kind that we are going to learn about. We're going to use what's called common cathode. And there's no difference between the 2 LEDs, the RGB LEDs. One is not better than the other. Some do have slight advantages, but mostly they're very similar. We're just using this one. So like I said before, we're going to have the LED looks like this, and have these pins. Okay, and this is going to be the red anode. This is going to be the green anode. This is going to be the blue anode. And this is going to be the common cathode. Okay, and remember, as we've learned before, the anode is going to be connected to what's going to be an input pin, and when you turn high signal, 3.3 volts on the anode, it will turn on, and cathode will be connected to ground. So wiring looks just like this, right? We've got our red, our cathode, our green, and our blue. And so similar to the way we would wire a regular LED, the anode comes through our resistor. Right, remember, there is our resistor. Comes through our resistor, goes to the pin, input pin, digital input pin on the argon. And the cathode is connected here to ground. Now what's different about this is that we have 3 anodes, which means we have 3 resistors. And on the argon, this is going to use 3 different input pins. And then we do have 1 cathode, which goes to ground. Now, you do need 3 distinct resistors. Same 330 ohm resistor that we've been using. We do need 3 of them, otherwise the LED doesn't typically work properly. So each anode needs its own LED, own resistor. Now, just a distinction to note here. Physically, meaning how they look, a regular LED looks the opposite of a RGB LED. So, if you remember, our regular one, so we'll say the regular, right, we have our cap, and then we have the long pin and the short pin. And this is going to be the anode. and this is going to be the cathode. So physically, the anode is the longer pin, right? But in the RGB, it's the opposite. We've got, this is the cathode, right, the longer one, and then the other shorter pins are the anode. So that's the only thing you really need to remember and keep in mind, right? In the regular LED, the long pin is the anode. In the RGB, the long pin is the cathode. Otherwise, your code is exactly the same. They are wired the same. You send a high signal, turn the anode on. You send a low signal, turn it off. You wire it with a resistor. Everything else is the same. Just for reference, so this, I'm just going to say, this is not in our class, okay? So I'm not going to spend too much time on this. I just want to point out that a common anode is basically the opposite. You end up having common anode. We have 3 different cathodes and 1 anode. It's kind of the inverse wiring. As you can see, there's a picture here of how you would wire it. I'm really not going to spend time on it. Just wanted to point out that it does exist. If you ever have problems with an LED, very rarely, it's possible that in manufacturing and packaging, the wrong LED fell into our kit. So that can be an issue. It doesn't typically come up, but I'm just pointing out that that might be a problem. Okay, so many of us are familiar with mixing colors, or at least understand the idea, right? And so if we think about, we open up a color picker, or we open up Photoshop or something like that, we can see that if we take red and we combine red with blue, right, what we get is magenta, right? So red plus blue equals magenta. And if we do red plus green plus blue, we get white. Okay, so we can use these colors to change the ultimate color we're looking for, and you can do this in any, word processing program in Photoshop, anything where you mix colors and you get to, do color picker. This is how we get to blend colors. Now, you would think that that's what we could do with an RGB LED, and we can to some degree, but in RGB light LEDs, red and green and blue do not exactly make white. If you turn them all on, you'll find that you get perhaps a light purple, maybe a light magenta, light blue, and that's just because these devices are manufactured to be cheap. I mean, they work fine, but they're not made to a specific tolerances and very detailed processes to make sure each one matches each other and each resistor matches each other and all these sorts of things. So what it ends up happening is that red, green, and blue do not actually make white. So for our purposes in this class, it doesn't really matter, but I'm just pointing this out. One thing that's interesting is if you look at, let's say, smart light bulbs, like smart LED light bulbs, where you can turn on, change the color with your phone, and you can put millions of colors by changing the color with an app. Oftentimes, these actually have 4 LEDs inside, or a series of 4 LEDs. They'll have a red, they'll have a green, they'll have a blue, and they'll also have a specific white bulb. And they blend these 4 colors to essentially make what we think of as color, purple, green, orange, but then they'll also use the white bulb to blend in to get more of a white or a yellow warm color.